What we have been doing is to try to analyze how the production in one region interacts with the production of another region, and so on. Well, to implement any sort of regional or geographical analysis, we need some empirical tools to measure economic structure. For instance, we talked about identified forward and backward linkages. But it's easy to say, well, I produce iron, so the car industry buys iron. You're assuming that the car production is the definition of an industry. But truth be told, to analyze backward and forward linkages, we need to define what an industry is to start with. Not only to define what an industry is, we need to be able to measure how regions are integrated. We are going to start to study empirical tools used by urban and regional economists. Basically, what we're going to be trying to do is to find some way to make measurements of how the production in a region compares to the production of other regions. In the next chapter, we're going to use that to learn how to measure and study economic growth. The first thing we need is to decide what an industry is. For instance, car production. How do we decide what kind of industry the kind production belongs to? Well, there is a coding system that does that. It is called NIICS, the North America Industrial Classification System. We used to have another code. It was called SIC, but then after NAFTA, Canada, Mexico, US, they got together and then decided to use the same coding system. So they invented a new one, such as to make sure that they were coding the industries in the same way so that we facilitate the measures of international trade. It's very useful to know that classification. In fact, a lot of the things that I'm teaching in this chapter, I'm using right now in a study that I'm doing with a co-author. And we are measuring the industrial production in the region. The first thing we did is we had to see the classification, the NIICS classification, and check based on that classification what industries were and were not present in that region. The codes in the NIICS are nested. For instance, 31 to 33 includes all the manufacturings. Now, 331 are the primary metal manufacturing. Inside this group is the 3312 steel product manufacturing from purchased steel, and inside that group is the 33121 iron, steel, pipe, and tube for purchased steel. So the classification varies from 2 digits to 6 digits, where each group that is in more detail or in more digits is encompassed inside a larger group, the group with less digits. Now, let's see where you can find these online. So I'm going to type here Census NIICS. That's where I look when I need to. And then I came to that page. And then you can see that from 5 to 5 years they update the code. The first NIICS code was in 2002. Sorry, the first NIICS code was in 1997. And since then they've been updating, as you can see here. Now, if you are looking for a code, let's see here, 48, which is 2-digit. 4849, transportation and warehousing. Then 4081 is a subgroup of this 2-digit one, air transportation. 4811, scheduled air transportation, and so on. Let's see another one. 11, agriculture, forestry, fishing, and hunting. And then inside this group 111 we have crop production. Inside crop production you have 1111 oil seed and grain farming, and so on. Okay, once we define what our industry is, we need to measure the level of industry specialization in a region. Basically, we want to measure the industrial composition of a local economy, and that can be better understood by comparing the local industrial structure with that of other cities or with the country as a whole. Okay? The idea is the following. Let's say that in US, 30% of the economic activity is manufacturing. But in Murray, let's say that only 10% in manufacturing. So you can say that compared to US, Murray is not concentrated in manufacturing, because in percentage terms is much less than the percentage terms in US as a whole. How do we measure that? We use location quotients, LQ. And here's the definition. The employment location quotient is the ratio of the percentage of regional employment in a particular industry to the comparable percentage in a benchmark area. Let's see an example of that. And in our case, just to make it easier, you're going to choose as a benchmark area the US. So LQI is the location quotient, I is the industry we're talking about, so each industry is going to have a different quotient. EI is the local employment in industry I. ET is total local employment. USI is national employment for industry I, and UST is the total national employment. Well, let's see an example. Okay, so I invented some easy numbers here. Let's say that the number of employees in the manufacturing sector in Murray is 20. The number of employees in Murray, including all sectors, is 100. The number of employees in the manufacturing sector in US is 400. The number of employees in the whole US, regardless of the sector, is 1,000. In that case, the location quotient would be plus 20 divided by 100, all of these divided by 400 divided by and that is 0.5. That makes sense given the numbers I invented. 20% of the employees in Murray are in manufacturing. 40% of the employees in US are in manufacturing. So compared to the US, half of the percentage in Murray compared to US is in manufacturing. What if we had a larger percentage? Let's say here 60. So in that case, of 100, 6 employees are in manufacturing. That's 60%. In that case, the local coefficient will be 1.5, larger than 1. Why? Because a larger percentage of employees are in manufacturing in Murray when compared to the percentage of employees that are manufacturing in the rest of the country. No, notice that if the percentages were the same, 40% for instance, in that case the coefficient is 1. That means that the percentage of employees in manufacturing in Murray is the exact same percentage of employee in manufacturing in US. Okay, here is an example of some industries. I'm using the beta industry like all industries, so the coefficient will always be 1. But in agriculture, for instance, in Cook County, Illinois, the coefficient is 0.02. That means that the percentage of employees in this sector in that county is way much smaller than the percentage of employees in that sector in the United States. Here are some other numbers. Now look at this wholesale trade. When compared to the rest of the country, the coefficient is 1, meaning the percentage of employees in that sector is the same in Cook County, Illinois, and in the rest of the country. Okay, now LQs, these two has a lot of advantages. First of all, it's very versatile. We used it to calculate employment, but you can use it to calculate anything, value added, sales, occupation. Instead of dividing employment percentage by employment percentage, we may be dividing value added percentage by value added percentage, or sales or occupation. So basically, depending on the research question, we can easily change the two. So it's very useful. We can also calculate the location quotients for linked activities. For instance, consider the following. Local grain storage in cubic feet and the local grain production. Okay? Now, for instance, this is local grain storage in US and local grain production in US. It is intuitive that for a given amount of production, I need proportionally some amount of storage. And let's say that in the country US, that's the proportion, say 20%. On the other hand, let's say that in Murray, Kentucky, this proportion is only 10%. Why would that be telling us? It's telling us that Murray needs more storage, that there's not enough storage for grain production in Murray.